is Tanyan Jun.
Hey guys, my name is Kai.
Hi, my name is Ami.
Hi,
we are from Group Network.
We will brief about
Graph theory and trees.
Graph theory is the mathematical theory of the properties and applications of graph, also known as network. The goal of this series is to gain an understanding of how to apply graph theory to real-world applications. Graph can be used to represent almost any problem, which makes them so interesting because they pop up absolutely everywhere. A simple problem that can be phrased as a graph theory problem might be given the constraints of in this picture. How many different sets of clues we can make using an article from each category. Another canonical example of a graph theory problem is the social networks of friends. A graph representation enables us to answer interesting questions such as how many friends this person X have, or how many degrees or separationary there between person X and person Y. Of course, this can be phrased and solved only using mathematics, but the advantage to graph theory is that it allows us to visualize the problem, using nodes to represent an article of clothing and edges to represent the relationship between them. It's the most simple kind of graph you will encounter. An undirected graph is a graph in which edges have no orientation. The edge UV is identical to the edge VU. For example, on the following graph, nodes are cities and edges represent bidirectional roads. Since if you drive to one city to another, you can always retrace your step by driving the other way. In contrast to undirected graph, there are also directed graph. A directed graph or digraph is a graph in which edges have orientations. For example, the edge UV is the edge from node U to node V. For this graph, you can only go to node U to V. So far, we only seen unweighted graph, but many graphs can have edges that contain a certain weight to represent arbitrary values such as cost, distance, quantity, and others. Weighted graphs come in both directed and undirected flavors. As a side note, usually an edge of such a graph will be denoted as a triplet, U, V, and W, and specify whether the graph is directed or undirected. In addition, there are many types of spatial graph. The first one is trees that we will be focusing in later. The next one is rotated trees, followed by directed cyclic graph, DAGS, bipartite graph, complete graph, and many more. Next, I'll pass to my teammate that will explain about tree graph.
Centers and bicenters. It is convenient to start building up the tree at the middle of a tree and move outwards. This was the approach used by Arthur Cayley when he counted the number of chemical molecules by building them step by step. But what do we mean by the middle of the tree? The center of a tree is a vertex with minimal eccentricity. The eccentricity of a vertex X in a tree G is the maximum distance between the vertex X and any other vertex of the tree. The maximum eccentricity is the tree diameter. If a tree has only one center, it is called bicentral tree. Every tree is either central or bicentral. If a tree has only one center, it is called bicentral tree. Every tree is either central or bicentral. For example, given a following tree, there are two straightforward ways to compute centers and bicenters. For algorithm 1, remove all the vertices of degree 1 together with their incidence edge. 2. Repeat the process 1 until we obtain enter a single vertex, the enter, or two vertices joined by an edge in left, then it is the bicenter or the tree. Secondly, for algorithm 2, for each vertex v of the degree 2 or more, count the number of vertices in each of the subtrees emanating from V, and let n power of V be the maximum of this number. If the tree has n vertices, it can be shown that either there is just one vertex V, for which n power of V less more 1/2 n minus 1, the entire tree, there are two adjacent vertices V and W, for which n power of V equals to n power of W equals to 1/2 n. The bicentroid or bicentroid tree. It is easy to see that every tree is either centroidal or bicentroidal, but not both. Note that we can think of the centroid or bicentroid as the center of gravity of the tree. For example, given a following tree. Since n power of C equals to 4, n power of E equals to 4, n power of F equals to 5, and n power of G equals to 6. Therefore, we have a bicentroidal with 3 bicentroid. Another example, given a following tree. Since n power of B equals to 6, n power of C equals to 5, and n power of D equals to 3, and n power of F equals to 5. Therefore, we have centroid D.
Depth first search, DFS. DFS is an algorithm starts at the root nodes and explores as far as possible along each branch before backtracking. In theoretical computer science, DFS is typically used to traverse an entire graph and takes time linear in the size of the graph. In these applications, it also uses space in the worst case to store the stack of verticals on the current search path as well as the set of already visited verticals. Thus, in this setting, the time and space of bounds are the same as for BFS, and the choice of which of these two algorithms to use depends less on their complexity and more on the different properties of the vertex ordering the two algorithms produce. Example, a depth first search starting at A, assuming that the left edge and assuming the search remembers previously visited nodes and will not repeat them. Since this is a small graph, it will visit the nodes in the following order: A, B, D, F, E, G, and C. Since this is a small graph, it will visit the nodes in the following order: A, B, D, F, E, C, and G. DH traverses in the search from a tree-marked tree, a structure with important application in graph theory. Performing the same search without remembering previously visited nodes results in visiting nodes in the order of A, B, D, F, E, A, B, D, F, and E, forever caught in the A, B, D, F, E circle and never reaching C or G. Breadth first searching BFF. There are many ways to traverse graph. BFS is the most commonly used approach. BFS is a traversing algorithm where you should start traversing from a selected node, aka source or starting nodes, and traverse the graph layerwise, thus exploring the neighbors nodes, the nodes which are directly connected to the source node. We must then move towards to the next level's neighbors node. As the example of the diagram first, move horizontally and visit all the nodes of the current layer, then move to the next layer. The distance between nodes in layer is comparatively lesser than the distance between the nodes in layer 2. Therefore, in BFS, you must traverse all the nodes in layer 1 before you move to the nodes in layer 2. That's all.
A forest is an undirected graph in which any two vertices are connected by at most on one path. Equivalently, a forest is an undirected graph, all of whose connected compound are tree. In other words, the graph consists of a disjunction union of three. POLYTREE. A POLYTREE is a directed arithmetic graph DAG whose underlying undirected graph is a tree. In other words, it displays the directed edge with understand. POLYTREE. A polytree is a directed discrete graph (DAG) whose underlying undirected graph is a tree. In other words, if we replace it directed edge with undirected edge with a then an undirected graph that is both connected and cyclic. Some authors restrict the paragraph related to the case where the edges are all directed toward a particular vertex or all directed away from a particular vertex. POLYFOREST. A polyforest is a directed cyclic graph whose underlying undirected graph is in a forest. In other words, if we replace it edge with undirected edge, we obtain an undirected graph that is a cyclic. Some authors restrict the paragraph directed forest to the case where the edges of each connected component are directed toward a particular vertex or are directed away from a particular vertex. Rotor tree. A rotor tree G is a connected cyclic graph with a special node that is called the root of the tree, and every either directed or indirectly originated from the root. An ordered root tree is a root tree where the children of each internal vertex are ordered. Ordered tree. An ordered tree is an ordered tree in which the children of a node are shown how ordered it is. A rotated tree in which an ordering is special for the children of each vertex. Labeled tree. A tree with it not labeled. The number of labeled tree on power n node is n power n negative 2. The first few values of each are 1, 1, 3, 16, 125, 1296. Carey provided the first fruit of number of labeled tree, and a constructive fruit was subsequently provided by Puffer. Puffer results give an encoding for labeled tree known as Puffer code indicated underneath the tree above, where the trees are distributed using an embedding with root at the node labeled. There is a few types of tree. First, a path graph. Second, a starlight tree. Third, a star tree. Fourth, a caterpillar tree. And lastly, a lobster tree. A forest is an undirected graph in which any two a polytree is a directed sorry.
Depth first search, DFS.
Siapa yang nak bilang?
Dia cakap lagi.
Another canonical example of graph theory problem is a social network of friends. A graph representation enables us to
Breadth first searching, BFF.
For centers and bicenters, it is convenient to start building up the tree at the middle of the tree and move out.
Graph can be used to represent almost any problem, which make them so interesting because they pop up absolutely everywhere. A simple problem that can be represented as a